So we're in Tech Math 2, section 2-5, which has to do with volumes of things. So if I've got a triangle type object and it happens to be a solid, then we would call that thing a prism. And the volume is going to be the base times the height. So I've got some height. I got to find the area of the triangle. So the volume would be 1/2 the base times the height of the triangle. And then, so that's what they're calling that big B, times the height of the prism. So I'd have some construction mark coming down. So it has some height on the prism, some B on the prism, and some height going up and down. And we're using the same things for H, so that's not good at all. That's very bad planning. We have a cylinder. So a cylinder would be like a hot water tank, for example. And I've got some radius R. I have some height. And the volume of the cylinder is going to be whatever that area of the circle is, 1/2 pi r squared times the height. And then we have a pyramid. And so I'm going to have some pyramid. A pyramid has a square base. So call it B. And we're going to go up and we're going to come down and we're going to come. Well, that's pretty bad, isn't it? Oh well. Oh yeah, see, it's pretty bad for a drawing, but can't have everything. So the volume of the pyramid is going to be 1/3 the base times the height. Now, are you going to memorize all these things? No. If it's on a test, you're going to raise your hand, I'm going to put it on the board, and you're going to use it. So you're going to use all these things, but you're not going to go and memorize all these things. Well, thank you very much. I want my blue marker. Thank you. Okay, then we have a cone. So a cone has some circle associated with it, radius R, and then it has some height H. So volume is going to be 1/3 pi r squared H. And in chapter 25, we actually show that that's the case. We have a way to prove that that is in fact the volume. Until we get there, we just have to do that. It also has a area R pi S, where S is the distance up the cone. And then we have the old sphere. And it's got a radius R. And the volume's 4/3 pi r cubed. The area on the outside 4 pi r squared. And again, we show in chapter 25 that in fact that works out. We use the calculus that we learned by then to show that that works out. But in this chapter, we're just going to go with that is the way it is. Now, your physics book, when you have your physics book next semester, has all these on their back cover, and that's a more easy place to get them. Trying to remember to go to page 101 of this book is not going to work very well. Okay, so let's start with working problems. We'll do number 1 just to get warmed up. Find the volume, the lateral surface area, and the total surface area of the solid rectangle. Okay, so we'll go with a picture. You can tell that my drafting skills from 7th grade are just so wonderful. Can't you tell that? Yes, of course you can. Admit it now or else. I forget who my drafting instructor was. I just adored the man. All right, so volume. I have 1, 2, 3 dimensions, so I got to multiply them all together. 72, 27, 27, 49, and 22.7. And if I had my calculator, I could multiply those guys together. Oh, I found it. And this is just another exercise of keeping the right significant digits, right? So I only have 2 significant digits, so that means 3. I have 3 significant digits, so my answer is 30,000 centimeters cubed, and I put a bar there to indicate that I have 3 significant digits. Now, the total lateral surface area. All right, so what is a lateral? Somebody threw in a multi-syllable word here. What is a lateral? All right, I'm playing football. What do I do with the football if I do a lateral? Do I throw it high in the air? Do I throw it high in the air? Or do I throw it that way? Yeah, it's a lateral because it goes back, right? It's a lateral because it's on the side. Okay, so lateral means I don't include the top or bottom. Okay, so that's when we say lateral, that's what we mean. All right, but we go back to our football analogy to figure out what it is, because our Greek is really, your Greek was really poor, right? In 8th grade when you took Greek, you did ancient Greek, you didn't do it well, right? Didn't do well in that class. All right, so that means I've got, so I want the lateral surface area. All right, so that'd be 27 times 49.4 times 2, because I have front and back. And then I've got this guy on the side, 27 times 22.7 times 2, because I have front and back. And then when I want total surface area, I'll take the lateral surface area, and then I'll add 2 times to get my top and bottom, and that will be 49.4 times what? 22.7, and then I'll remember that all my answers are in centimeters cubed. Centimeters squared, because that's the surface area. Centimeters squared, centimeters squared. Okay, ready for the calculator. 2 times, parentheses, not required though, 27 times 49.4 plus 27 times 22.7 times 2. Again, I have 3 significant digits, so I'm going to call this 3890 centimeters squared. Then I'm going to add 2 times 49.4 times 22.7. And I'm going to call that 614 centimeters squared. 640. I need a 0. When you know it. I need a 0 and I don't have enough room for it. 6140 centimeters squared. Okay, good enough? So the only weird thing there would be, what is a lateral surface? So a lateral surface is something that you paint. Do you paint the roof? Do you paint the basement? Well, you might paint the basement, but no, not without side paint. All right, number 3. Oh, we're working to get another student in here. So we'll have to wait for the dean to come back on Monday to convince her it's the right thing to do. All right, so number 3, I've got a pyramid. Okay, and I'm 18.6, 10.1. So I got a base that's going to be 18.6 times 10.1, whatever that number is. And then I've got a height. And a height, 24.6. Okay, that looks good. Find the volume. Okay, so volume is equal to, now we didn't memorize it, right? So we've got to turn back to see what it is. And 1/3 the base times the height. 1/3 base times height. 1/3 18.6 10.1 24.6. And when we get done, we're going to have inches cubed because it's a volume. And so the units have to be cubed. And we're only going to keep 3 significant digits. 0.5 times, oh, wait a minute, 1/3. 1/3 times 18.6 times 10.1 times 24.6. Yeah, it looks like I've got 1,540 inches cubed. All right. So we'll look at number 11 because that looks interesting. Number 11. A rectangular lead sleeve is shown below. Okay, so that begs the issue. If I have lead, what's that? What's the and I'm sending gammas through the lead. What's the half thickness of the lead? How many inches are required of lead to take the radiation down to half of what it is? And the answer is 2 inches of lead. Okay, so if I have 12 inches of lead, that means I have 6 times that I cut it by a half. So 1/2 raised to the 6th power is 1/64. Okay, so if I have 500 rem of radiation on this side of my 12 inches of lead, a field that within an hour will kill off 30% of the population in 30 days. Now on the other side, I would have 500 rem divided by 64. I only have 7.8 rem of radiation, but you can have a dose of 5 rem per year past your 18th birthday, and that's perfectly okay. So to hang out there for an hour, it's not going to do much to you much. To hang out there for a day or two is not going to be, is going to be really bad. So you're going to want to have more shielding than that. All right. I know you wanted to know that, right? Yeah. We used to teach those things in the middle of the Cold War when radiation levels after a nuclear blast were expected to happen. You know, we would teach those things to our children. Now we're kinder and gentler, and we don't tell them about it. And anyway, back to what we're doing here. How many cubic inches of lead are contained, and what is the weight of that lead? Okay. So what I'm going to do is find the volume. This is number 11, in case anybody was wondering. I'm going to find the volume of the hole. Okay, so the volume of the hole is 12 by 24 by 9. Okay, so 12 times 24 times 9. So I've got 2592 inches cubed. Now, we don't worry about significant digits until we get to our final answer. So it's okay to have 4 significant digits there. I wouldn't round off. Then I'm going to find the volume of the whole. So the volume of the whole is going to be, I've got an inch, I got 3 inches gone, right? 3 inches gone? Yeah, that's what it looks like. So that's going to be 9 times 6 times 24, because I didn't lose any the other way. 9 times 6 times 24, and 1296 inches cubed. So then I'm going to say that the volume is going to be the volume of the whole minus the volume of the whole. Okay, so 2592 minus 1296. 1296 inches cubed. And now we're worried about significant digits, and we only have 3, so we round that up to 1300 inches cubed. All right, now the second part wants to know, lead weighs 780 pounds per cubic foot. Okay, well, now we have to figure out how many cubic feet I have. So I have 1296 inches cubed, and that's going to be 1 cubic foot per 12 inches cubed. Okay, so now inches cubed goes away, and I only have cubic feet left over. So 12, whatever, divided by 12 squared, which is 144. So I have 9 cubic feet of lead. All right, so 709 pounds per cubic foot times 9 cubic feet. Cubic feet goes away. The only unit I have left over is pounds. Okay, times 709. And I have 6381. But again, I only have 3 significant digits, so I'd say weight of lead, PB, right? 6380 pounds. Okay. How much does it weigh on the moon? So, weight of lead on moon would be 1/6, because I'm 1/6 the gravity, divided by 6, so that'd be 1060 pounds. So on the moon it would weigh 1/6 as much. Did the mass change any? The mass on Earth is the same as the mass on the moon. So the mass didn't change, but the weight did. See, how come this guy's up so I can't see Ben? He's shaking his head like I'm wrong or something. Okay, number 12. You'd never do that, right, Ben? Never. Nah, you just tell me I'm wrong directly. You never do it indirectly. How many square feet of metal are needed to form the trough whose ends are semicircles and blah, blah, blah? How many cubic feet of liquid would it hold? Well, I think we'll do, so I've, oh, I don't know. So we'll draw a picture. That'll give you time to think about it. Oh, wonderful. So we're 28 inches right there. So that means my radius is 14 inches on the circle. And we have 24 feet going that way. So now we have two issues. We have the issue of feet, and we have the issue of inches, and we want to know square feet and cubic feet. So what we're going to do is we're going to change 14 to feet. 1 1.16 feet. 1.16 feet. Okay. So now we're gonna go for area first. Area. Okay, so area is going to be the two ends, 2 times 1/2, because it's only half a circle, pi r squared. So of course I'm not going to put the 2 or 1/2 in my calculator, it's just going to go away. Plus, I've got a circumference. The circumference is pi d. 1/2 pi d, because I only have half the circle, times the height. Okay, so that's what I'm going to do. So I'm going to say, okay, so that's pi 1.16 squared plus 1/2 pi 28. No, it's not 28. It's 2 into 6, 24. Alright, so now everything is in feet. When I get done, my answer will be in feet squared. Okay, now all I have to do is just do it. Alright, so 1 and, no, that's the wrong thing. 1 and 1/6. So if I look at my mode, I see that I'm in math print. Okay, so my mode is math print. And when I put in the number, I'm using second function shift key, second function 7. And that allows me to put in the fraction directly. So you did it all right. So well, you did do it all right. That's okay. So it allows you to put in the fraction directly, and then second function 17. It allows you to fill in a fraction directly, and then you don't have to worry about it being put in parentheses wrong. Just one of those weird things. Squared. Now that's going to square the whole fraction. Okay, so I've got that. Plus, let's see. I'm going to divide the guy by 2 already. I'll call it 1 and 2/6 again. Times times 1 and 1/6 times 24. I'm going to hit the enter button, and then I'm going to go times pi, because everything is times pi. And then I'm going to go third function and change the fraction to a decimal guy. And I'm going to get 29.2 feet squared. So that's the area. Now we want to know the volume. Okay, volume of a cylinder is pi r squared h. But it's not the whole cylinder, it's only half of it. Okay, so that'd be pi 1/2 pi 1.16 squared 24. And when I get done, it'd be feet cubed. Okay, so 0.5 times pi times second function, give me an improper fraction, 1 and 1/6 squared times 24. So I got 51.3 cubic feet. Okay, good enough? And we have 9 minutes to go. So I think we'll move to number 20. Number 20. Sheet metal is used to fabricate the tank. The ends are isosceles trapezoids. What does that mean? Well, that means the sides are equal on the sides, as shown in the figure below. How many cubic feet of liquid? How many cubic feet of liquid is stored when the level is at a half up the tank? Okay. All right, so that would be an interesting thing. All right, so I'm going to make a picture that looks like that. We know that this is 60, that's 80. If I do this, I have 24. And this goes back 12 feet. Okay, so I need to find the area of the trapezoid in feet, these are inches, in feet, and then multiply it by 12 in order to get the volume. All right, so the volume, okay, so I'm going to have 1/2 the height, 2 feet, times the two bases. So I'm going to divide 60 by 12, and I'm going to get 5 feet. And I'm going to divide 80 by 12, and I'm going to get 6 2/3 feet. And that's going to give me the volume. Okay? So 0.5 times 2 is a wash. I don't have to put it in. And all I'm doing is saying 5. 11. I'm just adding them. 11 2/3 feet cubed. Okay, so that's the A answer. The B answer, the water is going to be 1/2 of the way down. So I'm going to have the volume is going to be 1/2 times 1 times 5 feet plus. Now I've got to find this new line. Well, if it were 80 inches up there and 60 inches down there, and I'm halfway between, it's going to be 70 inches there, right? So 70 divided by 12. If I could put 70 divided by 12 on my calculator, is going to be 35/6 of a foot. So 6 goes into 5 is 5 point something. All right. Now, so that's going to be 1/2 times these guys added together. All right, so plus 5 equals times 0.5 equals, and I'm going to get 5. Well, let's see if that's a fraction. Yeah, so I'm going to get 5 5/12 of a foot cubed. Now, there's no reason why you couldn't have put down 5.4, right? 5.4 feet cubed would be perfectly okay too. I'm just practicing on changing things in my calculator. Yeah.
You forgot to multiply by 12 feet to get the whole thing.
Oh, bummer.
I'm pretty sure you can just multiply that answer by 12.
Yeah, I know I can. So the issue is I moved the marker down and I left out, I got the area, but I didn't get the volume. So I got to go 12 feet. I got to go 12 feet. So these guys are not right. 11. Okay. So I've got 11 and 2/3 times 12. That's 140. 140 feet cubed. And then I've got 5 and 5/12 times 12. 65. Yeah. Now, what happens in a tech math class is it's the duty of the front row to correct the instructor. Okay, so the student sitting in the front row, that you shouldn't allow Ben to correct you. There's nobody sitting in the front row. But if there were, it's there because the guys in the front row are closer to the problem, so I should correct that. All right. So it's not Ben's fault, that it's the front row's guy's fault for not correcting me sooner. Okay, good enough? All right, we're done with chapter 2. We don't have a test until the end of chapter 3. Yeah. All right, well, that'd be good. All right, see you in 10 minutes or so.